How are you? Today we come back to continue with our lessons. Last time, in the last video, we stopped at an example comparing the quantity and commodity and price, which is given as this. So I said in the last video, this is our Cartesian coordinate. We have P, price, Q, quantity, and we have a line here with 2 points on it, and we assume the line in the figure above shows the relationship between the price of a commodity in dollars and the quantity Q of the commodities in thousands. The consumers will buy at that price. So I said if the first point is given as 2,4 and the second point is given as 8,1, we find the slope. And I gave the formula for finding the slope in our last lesson, which is y2 minus y1 over x2 minus x1. So we are given 2 points, 2,4 and 8,1. All we have to do is we know how to find our x1, y1, x2, y2. In the first point I have x1, y1. In the second point I have x2, y2. So applying the formula, I will get a negative 1 over 2. So this is our slope. Now we want to interpret what this minus 1 over 2, that is the slope, means if you compare it with the price and the quantity. So let's see. The slope is minus 1 over 2, which is negative. This means that for each 1 unit increase in quantity, that is 1,000 commodity, there corresponds a decrease in price of minus 1 over 2. The negative sign is telling us there is going to be a decrease in price. If to say the slope is positive, there is going to be an increase in price. So the slope, which is minus 1 over 2, is saying for each 1 unit increase in quantity, there corresponds a decrease in price of 1 over 2 dollar per commodity. So due to this increase, the line falls from left to right. So that is the slope. So this is application in economics, business. So now we will show the mathematical application of what we mean if we are given a point, a line with points on it, on how to if we are given a line, on how to we will see how to find the slope of a line. So if you have a line and you know the points on that line, then you can use that points and find the slope of the given line. So this is an example. Find the slopes of the following lines whose points are given. The first example is saying we have a line, and on this line we have 2 points, 2,3 and 4,2. And the number 2, we also have another line which has these 2 points on it, and the third one and the fourth one. They are all lines, and these are points on the line. So we want to find the slope of this line. As simple as this. Apply the formula. You have 2,3 is the first point, 4,2 is the second point. For the first point, x1 is 2, y1 is 3. For the second point, x2 is 4 and y2 is 2. So the slope formula is change in y over change in x. Change in y is y2 minus y1 over x2 minus x1, which is change in x. So if you apply it, you will have minus 1 over 2. So follow the same procedure and solve the remaining examples, which is very simple. So now we have seen the distance between 2 points, the midpoint formula, and the slope. So this is where we are going to stop on the coordinate system. Though there are many things to do, but we will restrict ourselves to these 3 topics. We have so many things to discuss, but we will just stick ourselves to these 3. So the next topic is systems of linear equations. I think the first thing we do in this course is linear equations. We show how a linear equation the examples of how linear equations look like, and we solve some examples on linear equations and what have you. So now we are going to see what is going to happen if you have two or more linear equations at a time. That is what we call system. What is it going to happen if you have more than one linear equation, more than two that are occurring simultaneously? We saw how to solve linear equations in the topics we treated so far. Now we will see how to solve a system of linear equations. This involves two or more linear equations occurring simultaneously. They occur at the same time, but it is not one linear equation. We have two times 3, 4, and n times. We may have many linear equations that are occurring simultaneously. So now, examples. This is an example of a system. If you look at it, I have 3x minus 4y equal to 3 and 2x plus 3y equal to 3. This is two equations, two unknown. Two equations, two unknown. Two equations, two unknown. So this is an example of a system of linear equations. It consists of two linear equations. We can have 3, let's say 3x minus 4y plus another variable z equal to 13, and we can have x plus y minus z equal to something, and we can have another one like 2x minus 3y plus 6z equal to 0. So this is 3 equations, 3 unknowns. So it's also another system. But let's see how we solve this type of systems of equations. We have two linear equations in the variable x and y. So if we are asked to solve this system, all we are going to do is to find the value of x and the value of y that will satisfy each of the equations. The values you are going to find must satisfy each of the two equations, since we have two equations. If you have 3, the values you are going to find must satisfy all the 3 equations. Depending on number of equations you have, each value must satisfy your given equation. So let's see how we solve systems of linear equations. For now, we will treat just 2 equations, 2 unknowns, 2 equations, 2 unknowns. And there are other methods that you use to solve a system of linear equation. Many methods. We have the Cramer's rule. We have but for now, this I think we are going to just study elimination method and substitution method. These are the 2 methods that we normally use to solve simultaneous equation, that is 2 equations, 2 unknowns. These are the 2 methods. The first one is the elimination method, and the second one is the substitution method. So let's start with the elimination method. Let us demonstrate with example how we use this method to solve systems of linear equations. Example, solve the following systems using elimination method. So I have like 4 examples. The first one is this. Please, I use a curly bracket. This is saying these 2 equations are simultaneous equation. We normally represent systems in this form. So the first question is saying x plus y equal to 1 and x minus y equal to 1. The second example is saying 3x minus 4y equal to 13 and 2x plus 3y equal to 3, and this is the fourth example, and the third and the fourth one. So let's see how we use elimination method and solve this example. Let's start with the first one. The first one is x plus y equal to 1, x minus y equal to 1. The idea in elimination method is that we have 2 variables. Pick, depending on your choice and depending on how simple it will be for you to eliminate one of the 2 variables. Choose it. We don't have any rule in choosing, just choose. If I want to eliminate x, okay, eliminate x. If I want to eliminate y, eliminate y. So it depending on your choice and how simple it will be for you to eliminate. Eliminating is just like removing. We have 2 variables. We will perform some arithmetic arithmetic and eliminate either x or y. So this is our system, x plus y equal to 1 and x minus y equal to 1. Okay, I want to eliminate y. You may choose to eliminate x, but eliminating x and eliminating y is your choice, as I said, but the procedure or the operation you are going to use may differ. Just like this, I want to eliminate x and y, sorry, x plus y equal to 1, x minus y equal to 1. Okay, you are going to add, subtract, or multiply, or do whatever to eliminate x. But if you look at this system, we have x positive, y positive, y negative. If you add the two equations, you will have x plus x and y minus y, so y will go. If I want to eliminate x is positive in the first equation, x is positive in the second equation. The logical thing to do to eliminate x is subtract the two equations. X minus x will be 0 and y minus y will be y plus y, which is 2y. So you see, in this process I eliminated x. When I wanted to eliminate y, I add, but when I want to eliminate x, I subtract. So the operation may differ, but which variable to be eliminated, it is your choice. You choose the variable you want to eliminate. So here in the example, we want to eliminate y. So we add the two equations. I have x plus x equal to 2x as it is in the slide. Y minus y is 0, which is equal to 1 plus 1. So I have two equations. I want to add them. The result will give me one equation. X plus x 2x, y minus y plus 0, and 1 plus 1 equal to 2. So if you look at it, I have 2x plus 0, which is equal to 2, and this is just a linear equation. So solving this will give you x equals 1. So now you have x equal to 1. You have find the value of x. What is now left is for you to find the value of y, because we want to know what are the values of x and y that will satisfy the two equations. Now x is 1. How do I find y? You have x, you want to find y. You can choose any of the two equations. Choose the first one, substitute the value of x, you will get your y. If you choose the second one, substitute the value of x, you will also get your y. To find the value of y, we substitute the value of x equal to 1 to any of the two equations. No restriction. If you find the value of x, pick the first equation, is your choice, or pick the second equation, is your choice. Any equation you pick or you choose, the answer must be the same. So in this case, I choose the first equation, and the first equation says x plus y equal to 1. You know x, it is given 1, and you want to find y. So all you have to do is substitute the value of x. Here I have 1 plus y equal to 1. Take minus 1 to the other side, it will be y minus 1, or 1 minus 1, and you will have x equal to 0. So look at it again. You have the value of x. After eliminating y, you got the value of x. Now you want to find the value of y, and you have two equations in the system. Pick the first equation, is your choice, or pick the second one. The choice depends on you. So pick the first one or the second one, the answer will be the same. In this case, I pick the first equation, and the first equation is saying x plus y equal to 1. X plus y equal to 1. I know x, put the value of x, which is 1. I have 1 plus y equal to 1. This is a linear system, a linear equation. 1 plus y equal to 1. You want y. Check the value of, isolate the variable on this side and the other constants on the other side. You have 1 plus y equal to 1. Take 1 to this side, you will have y equal to 1 minus 1, which is 0. So now you have y equal to 0 and x equal to 1. These are the solution of your system. X equal to 1, y equal to 0. For these two values to be the solution of our system, they have to satisfy each of the equations. We have two equations and we got the values of x and y. Check these values in the first equation, check in the second equation. If they satisfy, then they are your solution. If they fail to satisfy the two equations, then they can never be a solution. So now put it. The first equation is saying x plus y equal to 1. Okay, x is 1, y is 0. 1 plus 0 is 1. So this is satisfied. The second one, x minus y equal to 1. X is 1, y is 0. 1 minus 0 is 1. So definitely x equal to 1 and y equal to 0 is the solution of our system. So the second example. The second example is a little different from the first example. The first example is straightforward, while the second example is not as straightforward as the first one. So we have this system. Let us eliminate y. As I said, eliminating the variable is your choice. You can choose to eliminate y, I can choose to eliminate x. It doesn't matter. If you follow the same procedure, if your procedure is okay, the result, my result and your result will be the same. So the procedure doesn't change the solution. So I want to eliminate y also in this question. Look at the first equation. 3x minus 4y equal to 13 and 2x plus 3y equal to 3. Okay, let's see. If we add, we will have 5x and we will have 5x minus y. 5x minus y equal to 18. So we didn't eliminate anything. 5x minus y equal to 18, because 3 plus 2 you will have 5x, minus 4 plus 3y you will have minus y, and 13 plus 3 you will have 16, sorry. So you didn't eliminate anything. Subtract also. 3x minus 2x will give you x. Minus 4y minus 3y will give you minus 7y. And 13 minus 3 will give you 10. So you see, you didn't eliminate anything by adding or subtracting. So adding the two equations and subtracting the two equations doesn't always eliminate the variables. So you have to do some mathematical manipulations. So what do you think if we multiply the first equation with 3 and the second equation with 4? As you can see from the slide, the coefficient of y in the second equation is 3. So multiply it with the first equation. And also the coefficient of y in the first equation is minus 4. So either multiply by minus 4 or plus 4. Just make them to be the same. If you have something like 12y in the first equation, 12y in the second equation, so you see there is every chance that if you add or subtract, the variable will be eliminated. So in the example, we multiply the first equation by 3 and the second equation by 4. Why? You will see the result. 3 times 3x will be 9x. Minus 3 times 4 will be minus 12y. And 3 times 13 will be 39. 4 times 2 is 8x. And 4 times 3 will be 12y. And 4 times 3 will be 12. So look at it now. You have 9x minus 12y equal to 39. And 8x plus 12y equal to 12. So what do you think if we add? If we add the two equations, definitely y will be eliminated. So all we did, we make the coefficient of y in the first equation and the coefficient of y in the second equation to be the same. In this case, if you add or subtract, they will definitely y will be eliminated. let me repeat again. The first equation will multiply by 3 and the second by 4. Our result is 9x minus 12y equal to 39, and the next one is 8x plus 12y equal to 12. Add the two equations. As you can see from the slide, when we add, we will have 9 plus 8, 17x, and minus 12y plus y will be 0. So you see y has been eliminated, and you will have 17x equal to 51. So now, straightforward, you can find x. 51 over 17 will be 3. So the value of x is 3. Now you have eliminated y and you have got the value of x to be 3. What is now left is take this value of x to either of the equations. Pick equation 1 or pick equation 2. It doesn't matter. If you pick any of the two equations, the result will be the same. So substituting the value of x in equation 2. Remember in the first example, when we got x, we substituted the value of x in equation 1. So here, we are substituting the value of x is in equation 2. So 1 or 2, it doesn't matter. So pick any equation. So from the slide, you can see equation 2 is 2x plus 3y equal to 3. So when we substitute the value of x to be 3, I have 2 times 3, 6 plus 3y equal to 3. Now I have 6 plus 3y equal to 3. What is now left is make y the subject and solve for y. This is a linear equation. You will have 3y equal 3 minus 6, which is minus 3. So you can see y is minus 1. Therefore, our solution is x equal to 3 and y equal to minus 1. So the idea is simple. Choose the variable to eliminate. If you choose x, eliminate x, you will find the value of y. If you choose y, if you choose y, eliminate y and find the value of x. Your result, take it to one of the two equations. Anyone, pick 1 or 2, and you will get the value of the other variable. So here x is 3 and y is minus 1. Check your solution. In the first equation, you have 3x minus 4y equal to 13. And x is 3. 3 times 3 will be 9, minus 4 times minus 1 will be plus. So it will be 9 plus 4, which is 13. So you see it is true. Put it in the second one. You will have 2 times 3, which is 6. 6 minus 3 will give you 3. So x3 and y minus 1 are the solution of our system. So try the third example and the fourth one. You will find it very interesting and straightforward and simple. So this is elimination method. The last method is the substitution method. So what do we have in the substitution method? We are going to solve the same examples we solve using elimination method and the substitution method. You will see that the result is the same. It's just the only difference is the approach. The only difference is the approach. So the result will be the same. So we have finished with the elimination method. Try the examples and many more examples. If you have it, you will find it very, very simple. So let's see the substitution method. We are going to solve the first example using the substitution method. In this case, no elimination. Nothing will be eliminated. We are going to use the substitution method. So forget about elimination. Now concentrate on the substitution method. So this is the idea. You have two equations. Pick the first one or the second one is your choice. Pick the first one, make x or y the subject of the formula. What you get, substitute it. If you pick the first one, from the first equation, you make the x or y the subject of the formula. Your result, put it in equation 2. Perform some arithmetic manipulations and you will have your answer. So let's see. We have two equations, x plus y equal to 1 and x minus y equal to 2. I pick the second equation, x minus y equal to 1, as you can see from the slide. I want to make x the subject. X is 1 plus y. I use a green color to highlight, to show you how the equations. I pick the second equation, x minus y equal to 1. I want to make x the subject of the formula. I take y to this side, and I have x equal to 1 plus y by picking the second equation. My result, take it back, put it in the first equation. I pick the second equation, and I find that x is 1 plus y. What you find, take it and put it in the first equation. So substituting this in the first equation, that is x, the first equation is x plus y equal to 1. But now you have changed, the value of x is 1 plus y. Remove x, put 1 plus y, and you have 1 plus y, which is in red here from the slide, plus x equal to 1. So this x, remove it, put 1 plus y, then plus y equal to 1. So you have 1 plus y plus another y equal to 1. Y plus y, 2y plus 1. Well, you see now, you have substitute the value of x in the first equation. That is why it is called substitution method. In the first method, elimination, you are eliminating, but here you are substituting. So now, you see we have 2y equal to 1 minus 1. 1 minus 1 is 0. 2y equal to 0, definitely y is 0. By dividing both sides by 2, you have y equal to 0 over 2, which is still 0. So now, you have y to be 0. If y is 0, substitute the value of y equal to 0 in the equation with green color. Please check the slide. As you can see, you will have x equals 1 plus y, and y is 0, you will have x equal to 1. So in the next video, we will continue with the substitution method, but try it. It is very, very simple. Thank you. See you later.